we'll be looking at power series solution of differential equation, right? Now, what we are doing here, or the whole idea is that, or just have it in mind that we just need the idea, right? Me knowing the idea, or me having the idea, whenever I see a question, I implement, right? That's it. That's what it means, basically. All right. When we now say power series solution of differential equation, now what we want to do is it is the basis of what we know previously, meaning we are adopting or we are implementing what we know, right? Now we are just using two basic approach here. The first one is nth derivative, and the other one is what? Binomial expansion. When I say nth derivative, meaning what? Higher derivative. You know, let's take it back to calculus, differential calculus. When we did differentiation, we said we can find the derivative of a particular function. We can find the derivative of a particular function, right? Say you are given y. Say you are given y is equals to 2x raised to the power of 4. This is the given function, right? I can find the derivative of this function repeatedly, right? Meaning the first derivative y prime is equals to what? 8x raised to the power of 3, right? The second derivative is equals to what? This is 24x squared. The third derivative, what do I have? I have 48x. The fourth derivative, what do I have? 48, right? Meaning that what I've done here, I can generalize it saying I have y raised to the power of n, right? Meaning I can find the derivative when n is equals to 1, meaning the first derivative. I can find the derivative when n is equals to 2, meaning the second derivative. I can find the derivative when n is equals to 4, meaning the fourth derivative, right? And so on and so forth. So what we are saying is that we can find the nth derivative of a particular function. We can find the what? Nth derivative of a particular function. But you observe that this nth derivative, we are still having that same function. We are still what? Having that same function. You know, in this case, let's say these are monomials. Meaning these are monomial function. When I say monomial, you know, we have quadratic, we have polynomial. So let's say these are monomial functions. You observe that the higher derivatives, they are still expressed as a function of x. Are you getting that? Are we together? You observe that the higher derivative, they are still a function of x. Meaning this first derivative is still having x as a function. This second derivative is still having what? X as a function. This third derivative is still having what? X as a function. This fourth derivative is just a constant value. But what we want to be doing is that I want to find the nth derivative. I want to what? Find the nth derivative. Meaning in this case, I want to express my derivatives in terms of n. I want to what? Express my derivatives in terms of n. We said, let's bring it back to what we know. I know that if y is equals to this, in differentiation, of course, I can perform the higher derivatives, right? Meaning this is the first derivative, this is the second derivative, this is the third derivative, and this is the fourth derivative, right? Meaning I've done higher derivative. But in this case, what we are doing is what? Nth derivative. We are doing what? Nth derivative. By nth derivative, those higher derivatives, I want to express it as a function of n. As a what? Function of n. So I'm saying that as far as power series solution of differential equation is concerned, it's still the basis of what we know. The first aspect is we doing differentiation. By differentiation, higher differentiation, meaning higher derivative. So we are referring that as nth derivative. While the second one is what? Binomial expansion. Binomial expansion. Binomial expansion. So basically, what we are saying is that the higher derivative is equals to what? Binomial expansion. But we'll be using product rule. We'll be using what? Product rule. Let's take it back to differentiation. In differentiation, I have three techniques, right? I have chain rule, I have product rule, and I have quotient rule. But just take note that when we are saying Leibniz Maclaurin series or Leibnitz Theorem, we are using the product function. We are using what? Product function. Just like we've seen here that if y is this, I can find the what? Higher derivative, right? Now let's say y is equals to uv. This is product rule of differentiation, right? So I want to find the higher derivative. I want to find the what? Higher derivative. Now in this case, what is my first derivative? Meaning y prime. Y prime is what? u dv over dx plus v du over dx, right? What's my second derivative? In this case, this is how it works. Now, given this function, say this is a product function. This is a product. This is from product rule, right? This is from product rule, right? So the idea now is that just all what we are doing, or the whole concept of Leibniz Theorem is that the higher derivative of a particular function, say product rule, is equals to the binomial expansion of that function. Now, this is what I'm saying. Let's say in binomial expansion, I say binomial theorem. Binomial theorem. Binomial theorem. By binomial theorem, say we have y equals to u plus v all square, and say we have y equals to u plus v all cube, and the last one, let's say we have y equals to u plus v all raised to power 4, right? And we have this. Say this is differentiation. This is differentiation. Right? We want to understand the concept behind Leibniz Theorem. We want to understand the concept behind Leibniz Theorem. We said Leibniz Theorem, what it means is that you want to find the nth derivative of a particular function. You want to find the nth derivative of a particular function. Just like we have in this case. Say you are giving this as a function. I can find the higher derivative, right? Meaning the first derivative, second derivative, third derivative, and fourth derivative, right? Meaning the higher derivative. So you can just generalize it saying y raised to the power of n, where n is equals to real value. Meaning if you want to find the first derivative, n becomes what? 1. You want to find the second derivative, n becomes what? 2. You want to find the third derivative, n becomes what? 3. You want to find the fourth derivative, n becomes what? 4. But we are saying that these higher derivatives, they are having x as a function, meaning we still have x present in the higher derivative, right? But by Leibniz is telling us that the higher derivative are expressed in terms of what? N. The higher derivative are expressed in terms of what? N. Now, the whole concept is that your say this is differentiation, meaning the product rule of differentiation is equal to your binomial theorem. Your product rule of differentiation is equal to your binomial theorem. Now, let's say you have this in differentiation. Say y is equals to uv, right? I can find the first derivative, right? I can also find the second derivative, right? I can also find the third derivative, the fourth derivative. Let's take one more, say fifth derivative, right? This is from product rule of differentiation. Similarly to binomial theorem, say you are giving this function. Say you are giving this function. What is the power of this expression? 2, right? What is the power of this expression? 3. What is the power of this expression? 4. Let's take one more. Say you have y is equals to u plus v all raised to the power 5. What is the power of this expression? 5, right? So we can write this as y raised to the power of 2, right? From this function, we can have this. This other, what do we have? Y raised to the power of 3. Next up, y raised to the power of 4. Then last, what do I have? Y raised to the power of 5. So by Leibniz theorem, we are saying that the answer we'll be getting for this product rule is equal to the answer we'll be getting when we use binomial expansion. So meaning in this case, the second derivative here, the answer for the second derivative is equals to the answer of this function when you use binomial theorem, right? By binomial theorem, we just need your Pascal triangle to know the coefficient, right? Similarly, we are saying that the third derivative of this function is equals to this. By the time you use binomial theorem to expand this, the answer you'll be getting is equal to the third derivative of this function. Similarly, the answer you'll be getting for y raised to the power of 4 is equal to the fourth derivative of this function, right? The answer you'll be getting for y raised to the power of 5 is equal to the answer you'll be getting for this fifth derivative. Are you getting me at all? So we are saying that for Leibniz theorem, the higher derivative of a product rule is equals to the binomial expansion of that same function, right? But we are going to see all of this. So that's what we want to do. We just want to see the proving behind it. not just proving, but we want to use it to write a series solution. We want to use it to write what? A series solution. And that's what we call the Leibniz-Maclaurin series. Meaning we are having Leibniz series and Maclaurin series. So the series solution we'll be getting from Leibniz, we are bringing it together with what? Maclaurin series. You know, when we say Maclaurin series, meaning Taylor series and the likes, right? Meaning we can have a function y is equals to s squared over 2 factorial plus s cubed over 3 factorial plus x raised to the power of n over n factorial. So what this topic means is that we are referring to Leibniz series and Maclaurin series, right? So we want to see the series, how we can write the series of Leibniz, right? How we can write the series of Leibniz theorem. Then we relate it to Maclaurin series, right? So let's do that. Let's say we are given that y is equals to uv, right? This is just the function itself, and we want to find the higher derivative. We want to find what? The higher derivative. By higher derivative, we are saying y prime prime, y prime prime prime, then y raised to the power of 4, right? Meaning the fourth derivative. So to understand what we are saying, we are going to differentiate this particular function 4 times. We are going to differentiate this particular function how many times? 4 times. Meaning I'm going to obtain the first derivative, the second derivative, the third derivative, and the fourth derivative. Now, say we are giving y. Say we are giving y as the product of these two functions, which is u and v. What's the first derivative? Your first derivative is what? Y prime is equals to what? What's y prime? U dv over dx plus what? V du over dx. This is the first derivative, right? Let's find the second derivative. When we say second derivative, meaning that in this case you are going to treat this as product true, and you are going to treat this as what? Product true. Meaning apply the idea of product true, get your answer. Apply the idea of product true, get your answer, then sum it up. It will give you the second derivative of this function, right? Now by doing that, I'm adding that y prime is equals to u dv over dx plus v du over dx, right? How it works is that we want to solve this particular function, right? You solving this particular function, what do you use? You make it a product true. By product true, you are saying that relate this as product true, then relate this as what? Product true, right? You know, this is the general formula for product true. U dv over dx plus what? V du over dx. So taking it one by one now, treating the two terms separately. Let's say this is 1, let's say this is 2. Now let's find the derivative of 1, meaning u. Okay, let's solve it here. Let's find the derivative of 1, right? Meaning what? U dv, meaning u dv over dx. In this case, applying product, what's my u? My u is still my u, right? This, I want to differentiate this using product true. This is u, and this is what? V. Applying this formula. Now, in this case, let's input value, meaning we are going to input the derivative and the function into this product true formula, right? Are we together? Meaning we are going to input the value. We are going to input the functions, which is function u and function v, and the derivative into this product true formula, right? Now, solving this using product true, this is my u, this is my v, right? Following product true formula, meaning I have what? U, right? I have u. The next one is what? Dv dx. Dv dx, identify what is your v? Your v is what? Dv dx. Differentiate dv dx. What do you have? D square v over dx square. Are you getting that? So it's complicated. What we are doing now is that we say we are giving this function uv, right? This is the first derivative. We want to differentiate this particular function 4 times. Meaning we want to find the derivative up to the 4th derivative, right? We say given this function uv, this is the first derivative, right? We are still going to differentiate this to obtain the second derivative. What does it mean? It means differentiate the first derivative. So if this is my first derivative, I'm going to differentiate my first derivative so I have to get the second derivative, right? But you observe that this on its own, you apply product true. This, you're also going to what? Apply product true. We are not saying that let's say this is the formula for product rule, or let's bring the formula for product rule out here. So applying this formula to these terms, or you say to this expression individually, say this is 1, say this is 2. Applying product rule to 1, meaning identify your u and identify your v. In this case, your u is still your u, right? The v dx is your what? V, right? Implementing product rule, you need your u, you need your dv dx, you need your v, you need your du dx. Now in this case, where will be your u? Your u is still your u, this is it. Multiplying dv dx, if this is v, dv dx becomes what? D square v over dx square, meaning you are differentiating this very guy with respect to x, right? So you have u d square v over the x square. Mind you, I've already applied this. Plus, what is my v? dv dx plus dv over dx. Multiplying what? Multiplying du, multiplying what? Du dx. If this is my u, the derivative becomes what? Du dx. Meaning multiplying what? Du over dx. So I got this answer just from 1, right? Same idea. Let's differentiate 2. We differentiating 2, meaning same idea, right? Now in this case, say we have 2, and we have v du over what? Over the x. This is my u, this is my what? V, right? Applying product rule formula, identify what is my u. My u is what? V, meaning I write v, multiplying the v dx. If this is v, the v dx becomes what? The derivative of this with respect to x, it becomes what? The square u over the x squared. From product rule formula, we've already implemented this, right? Moving to the next one that says v du dx. Come back to your function. What is your b? Du dx, meaning plus du over the x multiplying du dx. If this is u, du dx becomes what? The derivative of v. What is the derivative of v with respect to x? Dv dx multiplying dv over dx. Right? So what you've done here is that, say this is your function, right? Say this is your function. You differentiated this very function. You got this, right? You still have to differentiate this same guy. Meaning you treated this using product rule, and you treated this using what? Product rule. Observe that this guy, we've gotten this answer, right? This, we've gotten this. Meaning sum it up. By the time you sum it up, your result becomes the second derivative for this particular function. Right? Now, same idea. Same idea. We've gotten the first derivative, we've also gotten the second derivative. How do you go about the third derivative? Differentiate again. So let's sum it up. What do we have? Meaning we have this u d square v all divided by the x square plus the v over the x multiplying the u over the x, right? Plus v d square u over the x square plus the u over the x, the u dx multiplying what? The v over the x. Then from here, you what do you do from here? What do you do from here? Group, right? Collect like term. Collect like terms. Now, collecting like term, what do we have? It becomes u d square v all divided by the x square plus 2 du over the x dv over the x plus v d square u over the x square. Any question on that? No question. Input values, meaning your second derivative given this function becomes that very guy, right? It becomes that. So let's write. Meaning I'm having y prime prime is equals to what? Please call it for me. Y prime prime is equals to what? U d square v plus 2 du dx multiplying dv over dx plus v d square u over dx square. All right, this is the second derivative, right? Let's find the third derivative. Let's find the third derivative, meaning y prime 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 by y prime or by third derivative, we are saying that you are going to solve this using product rule, solve this using product rule, solve this using product rule, then sum it together. What we are doing is that we want to see how we can write the Leibniz series. I said it previously that the whole concept of Leibniz is that the higher derivative of two functions multiplying itself, say u and v, meaning product rule, is equals to what? The binomial expansion of that same function. So meaning that if we can say that the higher derivatives are equals to the binomial expansion, it means giving y equals to uv, we can find the nth derivative using binomial expansion. Using what? Binomial expansion. With that, we'll be able to write the series function. It becomes what? Leibniz series. But this is just the second derivative, right? Let's find the third derivative. This is still the second derivative, right? Let's find the third derivative. So with this idea, you'll be able to do that easily. So let's do that. From here, we want to find the third derivative. We want to find the third derivative. The question now is, how do we find the third derivative? So I'm saying that the way we found the second derivative, nothing is changing. Say you are given this, meaning the first derivative. We differentiated the first derivative, meaning we got the second derivative. We implemented or we applied product rule to this very term, right? Plus product rule to this term. Are you getting at all? Say we want to differentiate this, meaning we want to find the second derivative. What we did was that we observe, or we know that this particular term, we can relate it to product rule in differentiation. So we implemented this using product rule of differentiation, right? We got our answer plus this also, meaning the product rule of this answer, we sum it together, we got this, right? Now say you are given this function, or say you have this as your second derivative. You want to find the third derivative. What does it mean? It means apply product rule to this, get your answer. Apply product rule to this, get your answer. Apply product rule to this, get your answer. Then sum it up. Let's solve. We call a formula for product rule: u dv over dx plus v du over dx, right? So let's solve this using product rule. In this case, this is your u, this is your what? V, right? In this case, this is your what? This is your u, this is your v, this is your u, and this is your v, right? For easier calculation, let's say this is 1, say this is 2, and say this is 3. Now applying product rule to 1, meaning I'm having u the square v all divided by the x square, where this is u and where this is what? V. Implementing product rule, I need two derivatives and the known function, which is what? U and v. If this is u and this is v, to solve this term using product rule, what do I need? I need the v dx and du dx, right? Are you getting me? I need the v dx and du dx, right? Now in this case, applying product rule, I'm having u. What's my u? My u is still my u, right? So I'm having u multiplying the v dx. What will be the v dx in this case? If this is v, the v dx is what? Just differentiate, meaning the cube v over the x cube, right? Just differentiate this with respect to x. What do you have? We have the cube v over the x cube plus, following product rule, the next thing I see is what? V, right? What's your v? The square v over the x square, meaning plus the square v over the x square multiplying what? The u dx. If this is u, the u dx becomes what? If this is u, the derivative is what? The u dx. Are you getting me? From product rule, we've substituted our v, right? The next one is what? The u dx, meaning the derivative of u. And if this is u, the derivative becomes what? The u dx. So multiply by what? The u over the x. I've implemented, or you say we applied product rule to 1, right? Let's apply product rule to 2. We are applying product rule to 2. I have that 2 all into bracket the u over the x, 2 all into bracket the u dx multiplying what? The v dx. In this case, identify your u and identify your v, right? This is your u and this is your what? V. This is my u, this is my v. Same idea, right? Meaning I'm having 2 all into bracket What's your u in this case? Du dx, right? Let's do this together, please. What's my u in this case? Du dx. Meaning I'm having what? Du over dx. I'm having du dx multiplying what? Dv dx, right? No. We need to dv dx. D square v over dx square. This is product rule, and I'm having this function. This is u, this is v. My u, this is it. I've written it, right? Multiplying dv dx. If this is v, dv dx becomes the derivative of this guy, right? So let's differentiate. What do I have? I'm having d square v over dx square plus the next one I'm saying is what? V. Identify. What is your v? Dv dx, right? Dv dx. Right? Multiply what? Du dx. Your du dx becomes what? D square u over dx square. D square u over dx square. You are done with 2, right? Moving on. 3. I'm having v d square u all divided by what? Dx square. Identify your u, identify your v. This is your what? U. This is your what? V. Apply product rule. So let's do this together. That will be what? That will be what? V. V multiplying what? D cube u dx cube, right? D cube u dx cube. When we say u, this is u. Your v in this case is your u. This is it. The v dx. If this is v, how do you get the v dx? Differentiate. Just that. Once you assign a particular function being v, to get the derivative, just differentiate whatever that function is. If it is the second derivative, differentiate it. If it is the first derivative, differentiate it, right? That's what we did here. Plus, what's your v? The square u over dx square plus the square u plus the square u over what? Dx square. Multiplying what? Multiplying the dx. What is your dx? This is my v. This is it. This is v. U is v. The v dx. This is it. Plus v. What's v in this case? D square u over the x square. Multiplying the u dx. The u dx is what? The v dx. The v dx. Do you agree with that? This is v. This is what we are applying product rule to. Don't get confused. This is what we are applying product rule to. If this is u, if this is v, you want to get the u dx. Identify your u function and differentiate. So this is my u function. My u function is what? V. How do I get this guy? I differentiate, right? Meaning by the time you differentiate, what do you have? The v dx. Are you getting it? Any questions so far? Any questions so far? No questions. So I have what? Dv over dx. What do we do now? Sum it up. Sum it up. Identify the function having the same power, right? So let's identify. What do I have? I'm having u d cube v all divided by dx cube, right? Plus what? This and this can sum up, right? Yes. They are having the same power. Yeah. This is d square v divided by dx square multiplying. What do you say? Okay, plus this one, right? Let's treat this one last. Let's treat it last. I get me. So let's take this. This and this can sum up. So what do I have? I have 3 d square v all divided by dx square plus 3 dv over dx multiplying the square u over dx square, right? Plus what else? Then plus this, right? Plus v d cube u over the x cube. All right, we are going to use this. We will stop here. We are going to stop here. So with this, we understand what Leibniz series is talking about, or what it means by Leibnitz Theorem. We are going to stop here. We can go on and on, but what matters here is have the understanding of what we are doing. So we still going on saying we want to find the fourth derivative. It's still the same concept, right? But we are going to stop here. We are going to stop here. Now back to what I have initially. Meaning that y prime prime, which is the third derivative, becomes what? U cube what? Right? Plus 3 what? Plus 3 dv dx multiplying plus what? Any question on how we found this derivative so far? Because this is the basis of what we are doing. When we say Leibnitz Theorem, this is the basis. And I must tell you, or I must be sincere with you. By the time you understand this basis, moving on, or as we proceed, there's nothing strange. Because you are just referring to this idea. This is the basis, right? This is the basis. This is power series solution of differential equations 1, right? This is the first power series. Are you getting me? This is the first power series. When you go to the second power series, meaning Frobenius equation, once you know this, there's nothing hard. Now, once you know this basis, nothing is hard when it comes to Frobenius equation. Nothing is hard. But we said we want to understand Leibniz Theorem. We want to understand Leibniz Theorem. I'm not telling us that the whole idea of Leibniz Theorem is that your higher derivative is equal to your binomial theorem, or it is equal to your binomial expansion. Meaning, I want to find the higher derivative since the second derivative. I can use binomial expansion to find the second derivative. Say I want to find the third derivative. I can use what? Binomial expansion to find the third derivative. Are you getting that? Say I want to find the fourth derivative. I can use what? Binomial expansion to find the fourth derivative. If that being the case, meaning I can use binomial theorem to find the nth derivative of a particular function, then I have the series solution of that answer. Are you getting that? But you see what I'm saying now, right? Now up to this level, we call that we can write dy over dx as y prime, right? D square y over dx square as y prime prime, right? D cube y over dx cube as what? Y prime prime prime, right? Meaning all we have here is because the first one, meaning the given function y equals to what? uv, right? Y prime becomes what? uv prime, right? Plus du prime. This is the first derivative. Second derivative becomes what? uv prime prime plus 2u multiplying v, right? Plus v u prime prime. The third derivative becomes what? u v prime 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 plus 3 prime prime multiplying what? U plus 3v u prime prime plus what? vu prime prime prime. Now from here, this answer, before we move on to binomial expansion, looking at what we have on the board, I'm having two functions. The first one is what? U, and the other one is what? V. Now observe your power of U and V. You observe that one is increasing while the other is decreasing. You can relate that to what? Binomial expansion. By binomial expansion, say you have y equals to a plus b all raised power of 2, right? Say you have a plus b all raised power of 2. I want to expand this using binomial expansion. What do? A is increasing while b is what? Decreasing. It becomes what? A square plus what? A raised power of 1 plus a raised power of 0, right? The next one, what do I have? A raised power of 0 plus b raised power of 1 plus b raised power of 2, right? What do I have? a square plus a prime b prime plus b square. How do I get the coefficient? Using Pascal triangle. By Pascal triangle, I'm saying 1 1 1, right? 1 2 1. This is when your power is 0. This is when your power is 1. This is when your power is 2. Given this question, my power is 2. The coefficient becomes what? 1 plus 2a prime, sorry, plus 2a raised power of 1 multiplying b raised power of 1 plus what? 1b square. Let's assume that b prime is equals to b, right? And a prime is equals to a. Are you getting that? Meaning I have, what do I have? Meaning I have what? a square multiplying b plus 2a prime b prime plus what? Plus a multiplying what? B square. Any question? I said from here, let's assuming b raised power of 0 is equals to b and a raised power of 0 is equals to a. In a normally, this would have been my answer. What I got here, that's my answer using binomial expansion, right? But let's assume that b raised power of 0 is equals to b and a raised power of 0 is equals to a. Meaning from this answer that I've gotten, I have this, right? Any question so far? No question. Now, what we want to do is that doing comparison with what we found using binomial expansion and what we got here using differentiation. What is the difference between our answer? There's no difference, right? Meaning the power, in this case, my power is what? U and V. My power is what? U and V. My power is what? A and B. You observe that for this one, U is increasing while V is decreasing, right? What about this? A is increasing while B is decreasing. The coefficient is the same as this, right? The coefficient is the same as this. So we are saying that instead of you finding the higher derivative of a particular function, just like the way we've solved here, that we started solving for the first one, plus the second one, plus the third one, we can use binomial expansion. Using binomial expansion, you are still going to get the same answer as you using product of differentiation. Are you getting that all? Any questions so far? No question. Finding the derivative. Say you are giving this function. Meaning y equals to uv. The first derivative, we got this, right? The second derivative, we got this. The third derivative, we got this, right? You observe that for this first derivative, the power of u is increasing, right? While the power of v is decreasing. For the first derivative. Yes. For the second derivative, what do we have? The power of u is increasing, while the power of v is decreasing. Similarly, for the third derivative, what do you have? The power of v is what? Increasing, while the power of v is what? Decreasing. Meaning you can reverse the case. So this is what we got from calculation, meaning when we did the differentiation, when we found the derivative, this is what we got, right? So you reversing the case, it means you can have y equals to uv, right, which is the initial function. The first derivative, you can have it saying u is what? Decreasing, while v is what? Increasing. Similarly, for the second derivative, you can have it saying what? U is increasing, while v is what? Decreasing. Similarly, for the third derivative, then up to the last one, which is the fourth derivative. Are you getting at all? Yes. What we did was that, this is what we got from solving. When we found the higher derivative, meaning the first derivative, second derivative, third derivative. We are not saying that you observe that one function is increasing while the other is decreasing. If that being the case, we can reverse it as saying this, right? You can reverse it as saying this. So we are going with this. Meaning you will be using this, right? You are going to be using this. So what we want to do is that we want to understand Leibnitz Theorem. We want to understand Leibnitz Theorem. By Leibnitz Theorem, we are saying that the higher derivative, say you have a function multiplying another function, which in this case is u and v, meaning product u, is equals to what? Binomial expansion, or you say binomial theorem, right? Now, to confirm that, say you are giving y. Say you are giving y is equals to u plus v, right? And say you are giving y is equals to u plus v all raised to the power of 2. And also you are giving y equals to u plus v all raised to the power of 3. Then lastly, we are giving y equals to u plus v all raised to the power of 4. Now, I want to find the derivative of this given function. Are we together? We want to find the derivative of this given function using binomial, using what? Binomial expansion. And you know how binomial expansion works. You know how it works. How do you get a coefficient from Pascal triangle? From Pascal triangle, we are saying that I have this. This is 1, 1, 1, 1, 2, 1, right? 1, 3, 3, 1, 1, 4, 6, 4, 1, right? So I want to use binomial expansion to find the derivative of this function, right? I want to use what? Binomial expansion to find the derivative of this function. Now, for the second one, for the first one, meaning I have when y is equals to u plus v all raised to the power of 1. What do I have? I have u raised to the power of 1 plus what? U, right? Are we together? I want to use binomial expansion to find the derivative of this, right? So taking it from this first one, when y equals to all into brackets u plus v all raised to the power of 1. Using binomial expansion, what do I have? I have u raised to the power of 1 plus u raised to the power of what? 0. Then u is what? Decreasing, while v is increasing. So it becomes v raised to the power of 0, then v raised to the power of 1. How do you get your coefficient? Following Pascal triangle. By Pascal triangle, we are saying that for this, you have this coefficient when your power is 0. You have this coefficient when your power is 1. You have this coefficient when your power is 2. You have this when your power is 3. Then you have this when your power is 4. Right? So we've gotten this. Our coefficient becomes what? 1 multiplying u raised to the power of 1. Right? Multiplying v raised to the power of 0 plus 1 multiplying u raised to the power of 0 multiplying v raised to the power of 1. Therefore, I'm having u raised to the power of 1, v raised to the power of 0 plus u multiplying v raised to the power of 1. Right? Meaning that for this function, the derivative, I got what? Meaning for this function, using binomial expansion, I got this, right? Which is u raised to the power of 1, v raised to the power of 0, right? Plus u raised to the power of 0, v raised to the power of 1. Any question on that? No question. Now, moving on to the next one, which is this. Let's express this using binomial expansion. Using binomial expansion, what do I have? I have when y is equals to u plus v all square. What do I have? It becomes u square plus u raised to the power of 1, right? Plus v raised to the power of 0. The next one, v is what? Increasing. Meaning I have v raised to the power of 0, v raised to the power of 1, v raised to the power of 2. Substituting your coefficient, in this case, what your power in this case? 2. Meaning this becomes your coefficient. So you then have 1 multiplying u raised to the power of 2 multiplying v raised to the power of 0 plus 2 multiplying u raised to the power of 1, v raised to the power of 1 plus 1 multiplying u raised to the power of 0 multiplying v raised to the power of 2. So meaning for this function, using binomial expansion, you got this. So let's write. So I have u raised to the power of 2, v raised to the power of 0 plus 2 u raised to the power of 1, v raised to the power of 1 plus u raised to the power of 0, v raised to the power of 2. Any question? Now, for the next one, when I have the third function, meaning all into brackets u plus v all cube. Same idea. Using binomial expansion, what do I have? U raised to the power of 3 plus u raised to the power of 2 plus u raised to the power of 1 plus u raised to the power of 0, right? Meaning u is what? Decreasing, while v is increasing, right? So you have v raised to the power of 0, v raised to the power of 1, v raised to the power of 2, and v raised to the power of 3. How do you get your coefficient? Following Pascal triangle. Your coefficient becomes what? U raised to the power of 3, v raised to the power of 0, plus 3 u raised to the power of 2, multiplying v raised to the power of 1, plus what? 3 v raised to the power of 1 multiplying v raised to the power of 2 plus 1 multiplying v raised to the power of 0 v raised to the power of 3. Right? Any question on this? Therefore, when y is equals to u raised to the power of u plus v raised to the power of 3, I got the binomial expansion as u raised to the power of 3 v raised to the power of 0 plus 3u squared v raised to the power of 1 plus 3u raised to the power of 1 v squared plus u raised to the power of 0 v cubed. From here, we are going to stop here. Now, from here, what I just want you guys to do is that doing comparison between what we've got using the derivative and what we got using binomial expansion. What's the difference? Is there any difference? There's no difference. There's no difference. Right? You know, we got this answer using product rule. Using the product rule of differentiation, we got the first derivative, second derivative, third derivative, and the fourth derivative, right? Now using this binomial expansion, what's the difference? There's no difference. We are getting the same answer, right? So what it means is that, what's that?
All those, like v raised to the power of 0 now.
Okay, we are going to assume v raised to the power of 0 as v. That's it. You are not going to say 1. In anything raised to the power of 0 is 1. But in this case, v raised to the power of 0 is v. V raised to the power of 0, what's the question?
Normally, this is not going to be ascending because
What's that?
like the power, it's not going to be ascending.
No, this is what we got from differentiation. This is what we actually got when we use product rule. But we said u is what? U is increasing. While v is decreasing. Maybe one of the function is increasing while the other is decreasing. So if that be the case, you can reverse it, right? This is what I got initially, but you can still write it as this. You can still write it as this. Maybe given a question, it is your choice. You can assign a particular function being u, and you can assign another function being what? V, right? But back to what I'm saying, I said this is what we got from differentiation, and this is what we got from binomial expansion, right? Now, you observe that there's no difference, meaning in this case, the first derivative, meaning y raised to the power of 1, is equals to this expression, meaning when the power is 1 in this case. The second derivative, we got this. It's still the same thing as what? When the power is 2 in this case, right? So in essence, what we are saying is that, any questions so far? So in essence, what all of this means is that given that y is equals to uv, you know, this was the initial function given. You can still write that what y equals to, okay, given that y equals to uv, and you want to find the nth derivative. By nth derivative, we are saying y raised to the power of n, right? Let's say you are giving y equals to uv. You want to find the first derivative. Using binomial expansion. What do you have? You have y is equals to u plus v all raised to the power of 1. You have your answer, right? So you want to find the second derivative. How do you write it? You have y is equals to u plus v all raised to the power of 2. You obtain your answer. So you want to find the third derivative. How do you write it? You have y is equals to u plus v all raised to the power of 3. Now, questioner says that find the nth derivative. By nth derivative, meaning y is to the power of n, we can write that as u plus v all raised to the power of n. True or false? True. Meaning that the same way we solved this, is the same way we found the derivative of this using binomial expansion, we can also find the derivative of this using what? Binomial expansion. The same way we found this using binomial expansion, meaning the derivative using binomial expansion, we can also find the derivative of this function using binomial expansion. Then our answer, we are going to write it in terms of series solution. So that's what Leibniz series means. So it is telling us that you are using binomial expansion to find the derivative of a particular function. Using binomial expansion to find what? The derivative of a particular function. Say you have y equals to uv. Question says that find the nth derivative. You can write it as this. You writing it as this, what it means is that you can use what? Binomial expansion. Using binomial expansion, you obtain your answer. That answer, write it in terms of series solution. That becomes the Leibniz series. But we are studying what? Leibniz Maclaurin series. So meaning you are going to apply the knowledge of Leibniz series and Maclaurin series. Yeah. Now from here, let's say we have this. We want to find the nth derivative. We want to what? Find the nth derivative. From all what we've done so far, we've seen that u is what? Increasing. U is increasing while v is decreasing. U is increasing while v is decreasing. Now I can write this as, say I'm giving y is equals to u plus v all raised to the power of n. Meaning I want to find the nth derivative. Finding the nth derivative, I didn't know how it works. I need the u and v function, right? Where u is increasing while v is decreasing, and I need the coefficient, right? I can obtain the coefficient using what? Pascal triangle. But in this case, nth derivative, meaning the coefficient must be in terms of what? N. Must be expressed in terms of n, right? So meaning from what I have here, u is decreasing, meaning if u is decreasing, so it means I have u raised to the power of n, right? Multiplying v raised to the power of 1, right? Plus u raised to the power of n minus 1, multiplying v raised to the power of 2. Following all what we've done so far, by binomial theorem, this is what we got. In this case, for this second derivative, your u is what? Decreasing, while your v is what? Increasing, right? We now said giving y equals to uv. You want to find the nth derivative, you can write it as this, right? How do you find the nth derivative? Implementing binomial expansion. So we've seen that when you find the derivative of a particular function using binomial expansion, you see the same result using what? Differentiation, right? We now said from here, my u is decreasing. My u is what? Decreasing. Meaning I'm starting u with n. So let's say I'm having u raised to the power of n. The next one will be what? Minus 1. The next one will be what? Minus 2. Right? Where v is what? Increasing. So let's start with this very one. U raised to the power of n multiplying v raised to the power of 1 plus u raised to the power of n minus 1. The power of v is decreasing, while the power of v is what? Increasing. Meaning this one becomes what? V raised to the power of 2. Plus the next one is what? U raised to the power of n minus 2, right? Multiplying v raised to the power of 2. Any question on that? Sorry? Multiplying v raised to the power of 3, right? Plus u raised to the power of n minus 3 multiplying v raised to the power of 4. This is the function of u and v. How do I get the coefficient? How do I get the what? Coefficient? You know, my usual coefficient, I do obtain it from Pascal triangle. But in this case, nth derivative. Meaning those coefficients must be expressed or must be in terms of what? N. Must be in terms of n. Right? Now, your coefficient, it follows this order. You are having 1 plus n all into brackets n minus 1 all divided by 2 multiplied by 1 plus n all into brackets n minus 1 multiplying n minus 2 all divided by 3 times 2 times 1, right? Plus n all into brackets n minus 1 multiplying n minus 2 multiplying n minus 3 all divided by 4 times 3 times 2 times 1. Meaning that those coefficients we obtain or we do get from Pascal triangle. This is the formula in terms of n. Are you getting that all? Let's say for instance I'm having y equals to u plus v raised to the power of 2, right? I want to find this derivative using binomial expansion. What do I have? I have what? U raised to the power of 2 plus u raised to the power of what? U raised to the power of 2 plus u raised to the power of 1 plus u raised to the power of 0, right? Multiplying v raised to the power of 0, v raised to the power of 1, v raised to the power of 2, right? Now from here I want to get the coefficient. I want to get the what? Coefficient. Me getting the coefficient, what do I use? Pascal triangle. But I'm not using Pascal triangle now. I want to use this formula method. By formula method, we are saying that those values we obtain from Pascal triangle, this is the formula to it. This is the what? This is the formula to it. Now in this case, what's your n? Your n is 2. right? Your n is 2, right? Meaning I want to get the coefficient using this formula. It becomes what? What do I have? I'm having 1 plus, what's your n? Your n is 2 plus 2 plus 2 all into bracket 2 minus 1 all divided by what? 2 times 1, right? So meaning I'm having 1 plus 2 plus 2 all into bracket 1 all divided by 2, where this cancel out. So what do I have? 1 plus 2 plus 1. Meaning the coefficient for this expansion, you are having 1 plus what? Plus 2 plus what? 1. Which is still the same thing using what? Pascal triangle. You know, by Pascal triangle, I have what? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? This is when your power is 0. This is when your power is 1. This is when your power is 2. This is when your power is 3. Right? I would have substituted this coefficient using Pascal triangle, but I make use of what? Formula method, just to see how it works. Just to see how it works. So we got the same answer. Now let's say our coefficient, or let's say our power is 3. Let's say our power is 3. Meaning if my power is 3, this is my what? Coefficient. This is my coefficient. But using the formula method, what do I have? It becomes 1 plus 3 plus 3 all into bracket 3 minus 1 all divided by what? 2 times 1, right? Plus 3 all into bracket 3 minus 1 all into bracket 3 minus 2 all divided by what? 3 times 2 times 1. Simplifying this, I have 1 plus 3 plus 3, right? Plus this is 2 times 1 times 3. Gives it cancel out. So plus 1. Now compare it to what we have from Pascal triangle. You can see that it's the same. So we are saying that this is the formula for the coefficient. This is what formula for the coefficient of the expansion, which is still the same thing as using Pascal triangle. Which is still the same thing as using what? Pascal triangle. So from here, if y is equals to u plus v all raised power of n. So I want to find the nth derivative. By nth derivative, I really have the understanding that u is what? U is decreasing. I really have the understanding that u is decreasing while v is what? Increasing. Right? What's that? That's true. I'm supposed to be 0. Supposed to be 0. Thank you. This is 0. This is 1. This is 2. And this is 3. This is 3. We said, given that y equals to uv, right? Given that y is equals to uv, you can still write it as, we said, given that y is equals to uv, and question says that find y raised power of n. You can still write it as what? Y equals to u plus v all raised power of n. Right? You know, you want to differentiate this particular function. Are we together? You know, you want to differentiate this particular function. You differentiating this particular function, you can make use of binomial expansion, right? Why am I using binomial expansion? I'm using binomial expansion because I've seen that by binomial expansion, it's still the same answer using what? The derivative. It's still the same answer using differentiation. So meaning I can use a binomial expansion. Using binomial expansion, I've seen that u is increasing. Sorry, u is decreasing. While v is what? Increasing. So I'm saying I have u raised power of n. If u is decreasing, meaning it is subtracting 1. U raised power of n minus 1 plus u raised power of n minus 2 plus u raised power of n minus 3. Right? U is decreasing. Then v is increasing, meaning it is starting from 0. U raised power of 0 plus u raised power of 1 plus u raised power of 2 plus u raised power of 3. But the question now is, how do I get my coefficient? How do I get my coefficient? Take note, this is the formula for your coefficient. This is the formula for your coefficient. So writing this, meaning if y is equals to u plus v all raised power of n, then the nth derivative becomes u raised power of n, v raised power of 0, right? Plus, what will be the coefficient of this term now? N, right? You know, this is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one. Continuously, right? So me having this first term, I'm having u raised power of n multiplying v raised to the power of 0. What is the coefficient? 1, right? Plus this, plus u, okay, plus n multiplying u raised to the power of n minus 1, v raised to the power of 1, right? Plus n all into bracket n minus 1, all divided by 2 times 1, multiplying u raised to the power of, multiplying u raised to the power of n minus 2, multiplying v raised to the power of 2, right? Plus n all into bracket n minus 1, all into bracket n minus 2, all divided by 3 times 2 times 1, multiplying u all raised to the power of n minus 3, multiplying v raised to the power of 3. Any question? Any question? Any question? No question. Then continuously you have plus. Any question on this? Any question on this? No question. Meaning that we generalize the formula for the nth derivative of a product function. We've generalized the formula for the nth derivative of a product function. So we are saying that given y is equals to uv. Given y equals to uv, we want to find the nth derivative. By nth derivative, meaning y raised to the power of n. Given this question says that find the nth derivative. By nth derivative, meaning we want to find y raised to the power of n. You can express this question as this, right? By the time you express it as this, use binomial expansion. You using binomial expansion, you know that u is decreasing, meaning u raised to the power of n, u raised to the power of n minus 1, u raised to the power of n minus 2, u raised to the power of n minus 3, right? And you know that v is increasing, meaning v raised to the power of 0, v raised to the power of 1, v raised to the power of 2, and v raised to the power of 3, right? Now, how do you get a coefficient? By formula, this is your coefficient. The first term, the coefficient is 1. The second term, the coefficient is n. The third term, n all into brackets n minus 1 divided by 2 times 3. Just observe the pattern. The next one becomes this one. You are still repeating this, right? All into brackets n minus 2 divided by 3 times 2 times 1. The next one will now be what? N all into brackets n minus 1. You are still writing this. N minus 2, n minus 3, all divided by 4 times 3 times 2 times 1, multiplying u raised to the power of n minus 4, then v raised to the power of 4, right? So meaning this is the nth derivative of a product function. This is the nth derivative of a product function. And this is what we are going to make use of. If question says that find the nth derivative, all we need to do is just to record this, then substitute values. Right? Take note that v raised to the power of 0 is the same thing as v in this case. V raised to the power of 0, we are assuming it as what? V. So meaning I have just v for this. Any question on that? Oh, don't worry. Just take note that v raised to the power of 0 implies v, and u raised to the power of 0 implies u, right? Implies u. You know, normally, mathematically, v raised to the power of 0 would have been 1. U raised to the power of 0 would have been also 1. But in this case, for your series solution, v raised to the power of 0 is assumed as v. U raised to the power of 0 is assumed as u. So that's what we are saying. Meaning from this series solution, I have just v, right? So that's it. Meaning from here, I can rewrite all this as what? Series solution. You know, the topic itself is what? Leibniz-Maclaurin series, right? Leibniz-Maclaurin series. When we started, I said we have two topics here. The first one is Leibniz series, while the other one is what? Maclaurin series, right? So meaning what we've gotten up to this extent, it is called the Leibniz series. It is called the what? Leibniz series. Meaning when we say series, you know, this is how we represent series, summation, right? When we say series, or when you hear the word series, you know, this is the representation of series, meaning summation, right? So we are saying that all of these can be written in terms of series solution. All of this can be written in terms of series solution, and that's what we refer to Leibniz series. That's what we refer to Leibniz series. Now, from here, take note that I want to write, what we are doing is what? Leibniz series, right? By Leibniz series, I want to write a series solution for what I've solved so far, or for what I've gotten. So with this now, I've gotten this, right? I've gotten this. So I want to write the series solution. How do I write the series solution? You can only write the series solution when you express this n all into bracket n minus 1 divided by 2 in terms of combination, right? You can also write this in terms of series solution only when you express this in terms of combination, right? We are now saying that because that n combination r is equals to n factorial or divided by r factorial all into brackets n minus r factorial, right? So meaning me having n all into brackets n minus 1 all divided by 2 factorial, I can write this as 2 factorial. 2 times 1, 2 factorial. 3 times 2 times 1, meaning 3 factorial, right? So me having this, what it means is that I'm having n combination 2. Because that we have n combination r equals to n factorial all divided by r factorial all into brackets n minus r factorial, right? So meaning this particular coefficient is the same thing as this, right? This coefficient meaning n all into brackets n minus 1 multiplying n minus 2 all divided by 3 factorial is equals to what? N combination what? 3, right? Similarly for this, what do I have? N all into bracket n minus 1 all into bracket n minus 2 multiplying n minus 3 all divided by 4 factorial. You see the same thing as you writing n combination 4, right? So you can substitute all of this. Say this is 1, say this is 2, and say this is 3. Meaning you can substitute 1 into this general solution. You substituting that, what do you have? You then have, meaning I'm having the nth derivative of a product function, meaning y raised power of n is equals to u raised power of n, right? Multiplying v, right? Plus n multiplying u raised power of n minus 1 multiplying v raised power of 1 plus substituting this as this, right? So what do I have? I have n combination 2 u raised to the power of n minus 2 multiplying v squared plus n combination 3 multiplying u all raised to the power of n minus 3 multiplying v cubed, right? Any question? Plus n combination 4 multiplying u raised to the power of n minus 4 multiplying v raised to the power of 4 continuously, meaning plus n combination n minus 1 multiplying u all raised to the power of n minus r multiplying v all raised to the power of what? R. Multiplying v all raised to the power of r. Any question on that? Now from here, I said this is the first one. What is here? It's the same thing as this, right? What I have here is the same thing as this. This is the first term, u raised to the power of n multiplying v plus n multiplying u raised to the power of n minus 1 multiplying v raised to the power of 1, right? Plus I've substituted this in terms of combination. So I'm having n combination 2 multiplying what I have there plus n combination 3 multiplying what I have left, right? Plus n combination 4 multiplying what I have left, right? Meaning continuously. So by continuously, you are saying you have the general expression as this. You have the general expression as this. So any question? Any question? When you start solving, or when you take a question, example, you understand what I'm saying better. But you can still understand it this way. What I have here, this is n combination 4, and I'm having n combination n minus 1, right? Multiplying u raised to the power of what? Okay, for this one, I'm having multiplying u raised to the power of n minus 4 multiplying v raised to the power of 4. By derivative comparison, what's your r in this case? Your r is what? 4, right? You observe that n minus r multiplying v raised to the power of r. So it's still the same thing. If you have to go a step further, what do you have? Plus what? Plus n combination 5, right? multiplying u all raised to the power of n minus 5, right? Multiplying v raised to the power of 5. Meaning the sixth power, it becomes what? Plus n combination 5, multiplying u all raised to the power of n minus 6, right? Multiplying v raised to the power of 6. Meaning it keeps going, right? So you can just generalize it as plus n combination n minus 1, multiplying u all raised to the power of n minus r, multiplying v all raised to the power of r. So that's what we are saying. Any question? No question. Initially we said the whole idea is that I want to express what I've solved so far, or what we've gotten so far, as what? Series solution. We want to express all of this as what? Series solution, right? By series solution, this coefficient, which is the ratio of n to 2 factorial. You know, this is what this means, is that this divided by 2 factorial, this divided by 3 factorial, right? We said this coefficient can be expressed in terms of what? By combination, right? So we've done that. We've substituted all of those coefficients as combination. To now write the series solution, what all this is saying is that in terms of series solution, you are saying all of this, it implies y is equals to summation from r equals to 0 n combination n minus 1 u raised to the power of n minus r multiplying v raised to the power of r. That's what we are saying. That's it. Meaning this is the series solution, and this is what we refer to the Leibniz series. So this is the idea of Leibniz series. Any question? So this is the idea of what? Leibniz series. So this is what Leibniz series means. So what we'll be doing is that you'll be given a differential equation. Given this differential equation, we want to write a series solution. We want to write a series solution for that differential equation. We want to write a series solution for that differential equation. So we are saying that Leibniz-Maclaurin series. It means you are implementing the idea of Leibniz series and what? Maclaurin series. You are implementing the idea of what? Leibniz series and Maclaurin series. We've been able to derive the series solution of Leibniz series, right? What about Maclaurin series? Recall that your Maclaurin series, you can have it as y equals to y naught plus y raised to the power of 1 multiplying x raised to the power of 1 plus y raised to the power of 2, or you say y prime multiplying x raised to the power of 2 divided by 2 factorial plus y raised to the power of 3 multiplying x cubed divided by 3 factorial plus y raised to the power of 4 multiplying x raised to the power of 4 divided by what? 4 factorial. Meaning that as far as this topic is concerned, which is Leibniz-Maclaurin series, I'm implementing Leibniz series and I'm implementing what? Maclaurin. And I'm implementing what? Maclaurin series. So that's it. So let's take example. All we've learned so far, this is just the derivation. All we've learned so far, we want to implement it to a given question. Meaning, given a question, I want to find the nth derivative of that question. I want to find the nth derivative of that question. That's what I'm interested in. And I'll be able to find the nth derivative of a given question using what we have on the board. Using these formulas. That's how I'm going to find the nth derivative. Right? So let's take our first example.